In today's video, we are going to discuss about Cartesian product of sets and ordered pair. But before knowing what Cartesian product of set means, we first have to know what is an ordered pair. So an ordered pair consists of two or more elements written in a specific order enclosed within brackets. So for example, let's take two numbers A and B, and the numbers are then enclosed within a bracket. This is known as an ordered pair, where the first element is known as the first component or the first member, and the second element is known as the second component or the second member. Now, in case of an ordered pair, since the numbers within the ordered pair are written in a specific order, so if we change the order of those elements, the overall ordered pair will have a completely different meaning. So for example, let us take an ordered pair 2, 3, and let us take another ordered pair 3, 2. We see that both the ordered pairs have the same components 2 and 3, but written in different orders. Since the order of the elements written within the ordered pair are different, so these two are not equal. From this, it follows that if two ordered pairs A, B and C, D are equal, that is possible if and only if A is equal to C and B is equal to D. By this, we mean is that two ordered pairs are equal if and only if they have the same first and second component respectively. Now that we are familiar with ordered pair, we will now talk about Cartesian product of two sets. So let us take two non-empty sets A and B. Then the Cartesian product of A and B is the set denoted by A cross B, which consists of all the elements written in the ordered pair A, B, where A belongs to set A and B belongs to set B. In the set builder form, this can be written as A cross B is equal to the ordered pair A, B, such that A belongs to set A and B belongs to set B. Now, if A and B are two null sets, then A cross B will also be a null set. The Cartesian product of two sets can be better understood using a simple example. So let us take two sets, A, which consists of the elements 1, 2, and 5, and let us take another set B, which consists of the elements 2 and 6. Then the Cartesian product of these two sets can be obtained as follows. So first we will take the element from set A, since in the Cartesian product the set A is written first. So all the elements from set A will be the first component of the ordered pair elements. So first we will take the element 1 and find all the ordered pairs taking the elements from set B as the second component. Hence, the elements of A cross B will be 1, 2, 1, 6, taking the first component as 1. Now, again taking the first component as 2 and the second component as 2 and 6, we get the elements 2, 2 and 2, 6. Again, taking the first component as 5 and then the second component as 2, 6, we get the elements 5, 2 and 5, 6. One thing to note here is that the set A had 3 elements and set B had 2 elements. And in set A cross B, we see that A cross B consists of 6 elements. Since every element of the first set gives a ordered pair with all the elements of the second set, so we can say that if the first set consists of P elements and the second set consists of Q elements, then A cross B will have PQ elements. One more thing to note is that instead of A cross B, if we find B cross A, the elements of B cross A will be completely different, because in case of B cross A, the ordered pair will have all the first components from set B and all the second components from set A. That will give us the elements 2, 1, 2, 2, 2, 5, taking 2 as the first component and all the elements of A as the second component, followed by 6, 1, 6, 2, and 6, 5, taking 6 as the first component and all the elements in the set A as the second component. Now, since we have learned that ordered pairs are equal if and only if they have the same first and second components, so none of the elements in A cross B and B cross A are same. So we can say that for any two sets A and B, A cross B is not equals to B cross A. Now, there are a few more results we need to know about Cartesian product of two sets. The first result we need to know about Cartesian product of two sets is the Cartesian product of two sets is not commutative. However, if A cross B is equal to B cross A, that is possible if and only if A is equal to B. Generally, for any two non-equal sets A and B, A cross B is never equal to B cross A. The second thing we need to know is about distributive property. So Cartesian product can be distributed over union, intersection, and difference as follows. So let us take three sets A, B, and C. Then A cross B union C can be written as A cross B union A cross C. Similarly, A cross B intersection C can be written as A cross B intersection A cross C. And third, A cross B difference C can be written as A cross B difference A cross C. The third result we need to know is that for any three sets A, B, and C such that A cross B is equal to A cross C, then that is possible only if B and C are two equal sets. Now, while finding Cartesian product of two sets, we can also find the Cartesian product of a set with itself. So, for example, let us take a set A which consists of the elements 1, 2. Then A cross A is obtained by taking 1 as the first component and all the elements of set A as the second component, then taking 2 as the first component and all the elements of set A again as the second component. So A cross A will be a set consisting of the elements 1, 1, 1, 2, 2, 1, and 2, 2. Similarly, A cross A can also be found out using the same method. So A cross A is actually the Cartesian product of the above set A cross A with the set A. So that gives us the ordered triplets where the first element are taken from set A cross A, taking the ordered pairs 1, 1, 1, 2, 2, 1, 2, 2 as the first component and taking all the elements of A as the second component. That gives us the ordered triplets 1, 1, 1, 1, 2, 1, 2, 1, 1, 2, 2, 1. If we take 1 as the second component, followed by 1, 1, 2, 1, 2, 2, 2, 1, 2, and 2, 2, 2. If we take 2 as the second component. Now, there can also be cases where the Cartesian product of two sets are obtained in which both the sets have few elements in common. So, for example, let us take two sets A and B such that the number of common elements between them is P. And then A cross B and B cross A will have P square elements in common. That is, the cardinality of A cross B intersection B cross A will be equal to P square.
Thank you for watching. Check out the link to submit your questions for future solving sessions in the description box below. Make sure you subscribe to the channel and follow for more such videos. And I'll see you in the next one.